Welcome to Dresden. We're going to demonstrate our rail health fault simulator with remote attestation. Here you see our fault generator. What we can do here is we can generate different kinds of flat spots. Flat spots are ingrained here on a rolling stand, as you can see here. We can also change the bearings, and the bearings can be changed here with different faults, like inner fault and a bearing fault. We can adjust the weight, the load, via these screws, and of course we can adjust the speed. So let's go to 30 kph. Now we are in the fault-free situation. Here we have a sensor. The sensor is directly above the bearing. The signal is going to be sent to our computing unit, and when we start the computing unit, the signal is transmitted to our remote attestation device, which will then send results to our PC. So once we are in a fault-free state, you can see that we have no defects. Let's change to a fault state. Okay. Now we will go again from the sensor to our computing unit, back to the remote attestation, and you will then see over here the classification. Let's take a look at one more defect. Let's take a look at double faults. So here you see a double fault of different intensities and with a different amount of harmonics. This information is being sent through our remote attestation unit.
This attestation unit is an FPGA. It is connected via a network to a Raspberry Pi single board computer that is simulating a cloud server. The idea is that the FPGA, which is running the M3 operating system, sends the received sensor data to the cloud server. The state of the art is that this is happening using the transport layer security protocol, which is based on certificates. There's an authentication step involved, and this is used to determine if the correct endpoint is receiving the data. But there's no guarantee about the software that is actually in control of this device. So for example, if a malicious attacker managed to compromise the software running on the device, such that, for example, it leaks the data, and the sensor sends the data to the device, even though the TLS protocol is happening, it cannot know that the data that will now be sent to the malicious cloud endpoint will actually be leaked. The improvement that we made in the project is that we integrated the remote attestation protocol with the transport layer security protocol. And when we now send the data again, an additional step will take place during the transport layer security protocol handshake. During this step, a hardware root of trust built into the cloud server will compute a digital fingerprint of the software running on the server. And in this case, this software is not recognized and the connection establishment is aborted. If we load the correct software and then perform the test again, the combined remote attestation and transport layer security protocol will again compute a fingerprint of the now correct software that is running on this computer. And this digital certificate about the software running will now be recognized by the sensor device, and the data will be sent. And the sensor can be certain that the data will be used properly and not leaked. The sensor client running on the M3 operating system on the FPGA also attests itself to the server. On the client, RITLS requests an attestation report from M3's root of trust service. The cloud server checks the signature and accepts the client's attestation report if it recognizes the hash over the client-side software. In a separate test, we routed the RITLS connection through a simulated satellite link provided by ST Engineering iDirect. We captured what was happening during a complete transmission of sensor data from the FPGA client to the cloud server. On the top right, we see in real time what is happening on the client. We also captured packet traces during this test, which are shown on the bottom left and visualized on the bottom right. If we play back all these logs and traces in real time and in sync, we can see that only a small number of packets is exchanged and the latency is perfectly acceptable for the use case.